The guy you can see just on the top of this submarine is an explorer called Victor Vescovo. He'll begin leading a group of scientists into the deepest points
7 miles down. Pitch black darkness. Pressure that would crush a submarine hull like a soda can. And yet, on camera, something moved. Not drifting, not sinking, moving with purpose in a place where almost nothing was ever supposed to survive at all. For decades, scientists believed the deepest parts of the ocean were nearly lifeless, too cold, too dark, too crushing. But new footage from the bottom of the Mariana Trench is forcing researchers to ask a question they thought had already been answered. What if the deepest place on Earth isn't empty at all? What if it's full of life we never expected to find, behaving in ways nobody can explain? To understand how strange this footage really is, we need to go back to the deep-sea expedition that started it all. The 5 Deeps Expedition. In 2018, an American explorer named Victor Vescovo set out on one of the most ambitious ocean missions in history. His goal was simple: reach the deepest point of all 5 of the world's oceans, the Atlantic, Southern, Indian, Pacific, and Arctic, in one continuous expedition before the end of September 2019. This project officially became known as the 5 Deeps Expedition. However, there was one problem. No one had ever done it before. Even Victor Vescovo himself wasn't an oceanographer. Before turning his attention to the oceans, he had already climbed the 7 summits, the highest mountain on every continent, and skied to both the North and South Poles. Now, there was only one thing left to conquer: the deepest places on Earth. Unlike most deep-sea missions, this one wasn't backed by a government space agency or a major research institute. Instead, Vescovo used his own resources to fund this project, and the expedition officially began in December 2018. Its first destination was the Puerto Rico Trench, where Vescovo descended to Brownson Deep, nearly 8,376 meters below the surface. That single dive made history as the first crewed mission to the deepest point of the Atlantic Ocean. And that was only the beginning. Just 2 months later, in February 2019, he traveled to the South Sandwich Trench and reached the deepest point of the Southern Ocean. Once again, he made history. No person and no vessel had ever reached that location before. Then, in April 2019, the expedition moved to the Sunda Trench, south of Bali. There, Vescovo reached the deepest point of the Indian Ocean. But this dive delivered something even more exciting. The team discovered what appeared to be previously unknown deep-sea life. And then came the moment everyone had been waiting for: the Mariana Trench. By this point, Victor Vescovo had already reached the deepest points of 3 of the world's oceans. But the Mariana Trench was different. It was more than 2,500 meters deeper than the deepest trench he had visited so far. If Victor wanted to descend that deep into the ocean, he would need something that could survive conditions no human-made vehicle had ever faced before. The limiting factor. Before Victor Vescovo's expedition, only 2 crewed missions had ever reached the bottom of the Mariana Trench. The first one was in 1960, when Jacques Piccard and Don Walsh reached the bottom of the Mariana Trench aboard the deep-sea submersible Trieste. And the second one happened much more recently, in 2012, by filmmaker James Cameron. However, both of these dives had their limitations. The first dive, in 1960, lasted only about 20 minutes on the seafloor before beginning the journey back to the surface. Meanwhile, Cameron spent much longer on the seafloor aboard the Deep-Sea Challenger, but his submersible suffered equipment problems, including a hydraulic fluid leak that disabled one of its manipulator arms. It was also built for a single expedition, rather than routine exploration. Once the mission ended, the submersible was retired. Victor Vescovo wanted to change that. He wanted a submersible that could survive nearly 16,000 pounds of pressure on every square inch of its hull, freezing temperatures, and complete darkness. And do this again and again. So, Victor turned to Triton submarines, and what they created was nothing short of an engineering masterpiece. Their engineers designed the vehicle from the ground up to survive the most extreme environment on Earth. Instead of using the long, torpedo-shaped hull of a conventional submarine, they built it around a nearly perfect sphere. That spherical part was important because it could spread the crushing pressure of the deep ocean evenly in every direction. Unlike steel, titanium combines exceptional strength with relatively low weight, resists corrosion, and can withstand the crushing pressure found at full ocean depth. Around this titanium sphere, they installed 3 acrylic viewports strong enough to withstand the immense pressure and 10 electric thrusters. And in case something went wrong, it also carried emergency life support systems capable of keeping its 2-person crew alive for up to 96 hours while waiting for rescue. And now there was only one thing left to do: put it to the ultimate test. The Mariana dive. On the morning of April 28, 2019, the moment had finally arrived. The Pacific Ocean above the Mariana Trench was unusually calm. The sea looked almost like glass, the perfect weather window it had been waiting for. Victor Vescovo climbed inside the DSV limiting factor. Then the hatch closed, and the descent began. For the next 4 hours, the submersible slowly sank toward the deepest place on Earth. At first, sunlight streamed through the water, but with every passing meter, the light grew weaker until it disappeared completely, leaving the limiting factor surrounded by total darkness. As the submersible continued its descent, it passed through the thermocline, a layer where the ocean temperature suddenly dropped. Soon, the water settled at just above 1 degree Celsius. At this point, there was no sunlight, no fish swimming past the windows, only endless darkness. And every second, the pressure kept increasing. Then, after descending almost 11 kilometers, the limiting factor gently touched the seafloor of Challenger Deep. Its instruments recorded a depth of 10,928 meters, making it the deepest crewed dive ever completed and beating the previous world record by 16 meters. But the scientists wanted to know the exact depth. So, after the expedition, they compared the dive data with measurements collected by 3 robotic seafloor landers. And when all of the data was combined, the final depth was refined to 10,935 meters. At that unimaginable depth, Victor spent more than 4 hours exploring the seafloor before beginning the long journey back to the surface. It was the longest time anyone had ever spent at the deepest part of the ocean. For almost anyone else, that would have been enough. Just 3 days later, on May 1st, he climbed back inside the DSV limiting factor and repeated the entire descent. 4 more hours, another journey through freezing darkness, another descent, nearly 11 kilometers to the bottom of the Mariana Trench. And with that second dive, he became the first person in history to reach Challenger Deep twice. But the records were never the most important part of the expedition, because what Victor found during those 2 dives would completely change the way scientists looked at the deepest place on Earth. The hidden life forms. For most of the 20th century, scientists believed the Hadal Zone, the parts of the ocean deeper than about 6,000 meters, was almost a biological desert. They thought the crushing pressure, freezing temperatures, and complete darkness made it nearly impossible for life to survive there. At best, they expected to find only a few microbes or the occasional scavenger. For decades, that was the accepted view of the deepest place on Earth. But once the lights of the DS5 limiting factor cut through the darkness, that entire assumption began to fall apart. The seafloor should have looked empty. Instead, the small patch of sediment illuminated by the submersible was crawling with life. To understand just how surprising this was, the team lowered a bait canister onto the seafloor and waited. Within only 20 to 30 minutes, the first amphipods appeared. At first, there were only a few, then dozens, then hundreds, and before long, Vescovo described thousands of amphipods converging on the same few square meters of mud. And these weren't the tiny amphipods most people might recognize from shallow coastal waters. Some of the individuals measured between 4 and 12 inches long. Their bodies were pale, almost transparent, giving them an almost ghost-like appearance under the bright white lights of the submersible. And they weren't alone. Instead of hunting, they swallowed the top few millimeters of sediment, extracting every tiny piece of organic material hidden inside before moving on to the next patch. Finding this many animals was surprising enough. But as scientists looked closer, they realized the abundance of life wasn't the biggest surprise. It was the incredible variety of creatures living in one of the most hostile environments on Earth. The incredible diversity. The deeper Vescovo looked, the stranger everything became. It wasn't just that there was more life than expected. It was that there were so many different kinds of life. At around 7,000 meters, the cameras recorded a spoonworm, a soft, segmented animal that had never before been seen at that depth. Then, about 1,000 meters deeper, at nearly 8,000 meters, another remarkable creature appeared. A snailfish. It was pale pink, measured between 7 and 11 inches long, and its skin was so thin that parts of its internal organs could actually be seen through its body. But the thing that surprised the researchers the most was how it was surviving there. At a depth of 8,000 meters, the pressure exceeds 1,000 bars. To put that into perspective, that's roughly the same as placing 50 fully loaded jumbo jets on top of a single person. So what was the secret that let these fragile-looking creatures survive under such crushing pressure? When researchers studied the cells of these snailfish, they found a surprising chemical, TMAO, short for trimethylamine N-oxide. This compound helps protect the fish's proteins, preventing them from being crushed and damaged under the immense pressure of the deep ocean. In fact, scientists found that the deeper a fish lives, the more TMAO its body must contain. But even that has a limit. Researchers have calculated that around 8,200 meters, the amount of TMAO needed becomes so high that the fish's cells would begin absorbing seawater faster than they could survive. In other words, beyond that depth, being a fish may no longer be physically possible. And the Mariana snailfish lives almost exactly at that boundary. It appears to exist right at the very limit of where any fish on Earth can survive. But surviving at these depths was only part of the story. The biggest surprise wasn't the animals themselves. It was how they behaved. The shocking behavior. The more researchers watched, the clearer it became. These weren't animals barely hanging on to life. They were animals that had evolved and thrived here for millions of years. When the researchers lowered bait onto the sea floor, the amphipods didn't slowly drift toward it. They rushed it. Within just 30 minutes, hundreds, and then thousands had gathered around the bait. They climbed over one another, pushed through the crowd, and competed fiercely to reach the food first. That wasn't what scientists expected to see. For most of the last century, Researchers believed animals living this deep would have to conserve as much energy as possible. Food was thought to be so scarce that life at the bottom of the ocean should have been slow. But the footage told a completely different story. Instead of a nearly lifeless sea floor, scientists were looking at a busy ecosystem. The amphipods acted like fast-moving scavengers, extracting every tiny piece of organic material buried inside it. Worms worked beneath the mud, and above them all was the snailfish, the top predator of an ecosystem with no larger hunter to challenge it. For centuries, many scientists had imagined the deepest part of the ocean as a place where life barely survived. Instead, it looked like a functioning community. But there was one problem. Where were all these animals getting their energy from? The energy problem. For decades, scientists believed the animals living inside these trenches survived on something called marine snow. Marine snow is a slow, continuous shower of dead plankton. At first, that explanation seemed to make perfect sense. But when scientists ran the numbers, the theory began to fall apart. The food had to sink through nearly 11 kilometers, or almost 7 miles, of ocean. By the time it finally reached the bottom of the Mariana Trench, only about 1 to 2% of the original organic material was still left. That simply wasn't enough to support this huge community living down there. So, scientists began looking for other sources of energy. Every once in a while, a dead whale or shark sinks to the bottom of the ocean. These events, known as food falls, can deliver more food in a single day than years of ordinary marine snow. A single whale carcass can feed deep-sea animals for years, attracting scavengers first, then bacteria, worms, and many other species. But food falls are rare. They couldn't explain why life seemed so abundant across the trench. Then researchers noticed that the shape of the Mariana Trench itself might be the key, because it isn't a wide, flat basin. Instead, it is a steep V-shaped canyon. Scientists think the trench's steep walls funnel leaves, dead animals, and other organic material down to the deepest point. Instead of food being spread evenly across the sea floor, the trench may naturally collect it in one place. But even that may not be enough. When researchers collected sediment samples from the bottom of the trench, they found communities of bacteria living inside the mud. These bacteria weren't using sunlight to make energy. There isn't any sunlight nearly 11 kilometers below the surface. Instead, they were using a completely different process called chemosynthesis. Rather than capturing energy from the sun as plants do, these microbes produced energy from chemicals such as methane and hydrogen sulfide leaking out from deep inside the earth. If scientists were right, then at least part of the deepest ecosystem on Earth wasn't surviving on leftovers falling from the surface. Instead, it may be fueled by several different sources working together. By this point, Vescovo's expedition had revealed a thriving ecosystem, extraordinary biodiversity, and multiple sources of energy capable of sustaining life nearly 11 kilometers below the surface. But when all of these discoveries were viewed together, they raised an even bigger question. If life could survive here, what did that mean for the rest of our planet, and even beyond it? The scientific importance. For decades, scientists believed life was most likely to exist where liquid water and suitable temperatures could be found. This concept became known as the Goldilocks zone, but the Mariana Trench challenges every part of that idea. Nearly 11 kilometers below the surface, there is no sunlight. The water stays just above 1 degree Celsius. The pressure exceeds 1,000 bars. Yet, life here isn't just surviving, it's thriving. Entire food webs competing for survival in complete darkness. And if life can exist in an environment this extreme, Could it exist elsewhere under the same conditions? That question has completely changed the way scientists search for life beyond Earth. Take Europa, one of Jupiter's moons. Scientists believe a vast liquid ocean lies hidden beneath 10 to 15 miles of ice. In fact, that hidden ocean may contain more than twice as much water as all of Earth's oceans combined. Then there's Enceladus, a small moon orbiting Saturn. Spacecraft have detected enormous plumes of water vapor shooting hundreds of miles into space. Neither of these worlds receives enough sunlight to support life the way Earth does. But after the discoveries in the Mariana Trench, scientists no longer think sunlight is the only answer. Instead, they now see Earth's deepest trench as one of the best natural laboratories for understanding what life on these distant worlds might look like. And perhaps the most incredible fact of all, the world's Hadal trenches cover roughly 45,000 square miles of seafloor, an area larger than the entire state of Ohio. Yet scientists estimate that humans have visually explored less than 0.01% of them. Think about that for a moment. More than 99.99% of the deepest places on Earth remain unseen. And if every expedition so far has returned with discoveries that nobody expected, there's every reason to believe the next one will too. So here we are. For centuries, people imagined the deepest place on Earth as a cold, empty abyss where almost nothing could survive. But every dive into the Mariana Trench has revealed the exact opposite, a hidden world filled with strange creatures, entire ecosystems, and mysteries that scientists are still struggling to explain. So, after hearing all of this, what else do you think is waiting nearly 11 kilometers beneath the surface? And could the greatest clue to finding alien life be hiding at the bottom of Earth's own oceans? Let me know your thoughts in the comments below. If you enjoyed this journey into one of the last unexplored places on Earth, make sure to like this video and subscribe to the channel. Thanks for watching, and I'll see you in the next video.